Okay, so now we have the map contains blue clean neighborhood polygons and land use with zoning types, and we will use the blue clean zoomed bookmark to get to blue clean. And the feature clearly do not share the same boundary and that we have. Let me close this out. I don't need any tools right now. And we will see neighborhood with mixed zoning types. So right here, open tables to study the attributes first. So right now, study the attribute table for each feature class will help to become familiar with the attribute before we use the union tool. And there are 52. I really don't like the docked default. I don't know where to change it at. Okay. And there are 52 neighborhood polygons, so I have to drag it. Not this one. This is the, let me resize it. It's just too crazy when you have a big screen. I don't really like it. When it docked, I mean. So, okay, 51, and the other, we have a lot of stuff going on here. The table contains no data about land use in the feature class, but it does contain data about population and housing units in each neighborhood. We open the this is land use table, and it contains information about what type of this, whether it's residence or something, and we will see if they have the same field. Area, land, zone, something. R4. Okay, the shape, length, and stuff might be the same field. The shape and FID and object ID. So, both table includes length and area for every polygon. That we can do union. So, and the union feature, we will go to analysis and the geoprocessing tools union. So for union, that we will review all the tools when we are done working on this. So on the analysis tab, we did click union, and in the geoprocessing pane, we will do Brooklyn and neighborhoods, and then we will do land use. Okay. And this two table, and we will add them things together. Union is fine, attribute, gaps allow, and make sure we saved it in data. Okay. Let's just use default. Okay. Go to run. Run the tool, and after it, we will close it. After it finishes, the result is a new layer of smaller polygons with combined neighborhood and land use data. And we will turn off both of this layer. Union. Okay, now union is done, and we will open the attribute and see what's the difference. Okay, and now it's kind of like combined, but we do have a little more field. So let's back in our bullet clean again, and let me just, I could just dock this there. There, okay. So the idea is you can go back and forth into different layers there, which is a good idea for docked. And then I'm gonna highlight this. Where is the union layers? Folders, tutorial. Where did it go? Photos chapter 6. Okay. So let's just add data, it's in the folder, I know. Tutorial, index. Where's union? Okay, let's run it again. Analysis, union. Okay. And then, 1, 2, Okay, all attribute. Okay, I'm gonna save it in my database called Union. Run. Okay, so Union is this. Okay, and if we do this and we do this, okay, this is Union. All right, let's see what is the difference between Union. Oh, Union is here. It's a table. Oh, right here. Yeah. Okay. He added here 51. Okay. All right. So we did observe a little bit. So and then we turn off that and we click one of the polygons. So and then we will see. For example, we click one of the polygons and we see the value of neighborhood and land use at the same time. See land use and everything. And we will calculate acreage. A field for the area or acreage of each polygon created by the union is needed before the land use can be summarized for neighborhoods. So, and we will do is here we will click add geometry. So on the analysis tab, click the tool button and search for add geometry attributes. So now tools, add geometry attributes, add geometry attributes, the first one. It's a Python script tool. And inputs we will do is the union layer, and geometry property we will do area, length unit, feet United States, and area unit it will be acres, and coordinate system it will be New York, current map. Let's see, no, not this one. Let's see. 1980, NAD 1983 State Plane, New York, Long Island, FIPS 3104 feet, and click run, and then we will open the attribute table. This to the right. Okay. Union is right here. Okay, now I think right here it's the shape area and poly area. Isn't it the poly area? Okay, yeah, that's the poly area. So scroll to the right and right click on here and sort we will do is descending. Okay. So we're going to select and summarize residential land use area for neighborhoods in the contents pane, which is right here. Right click on Brooklyn Neighborhoods Land Use Union and we will click properties. So click definition query, we will go to definition query and then we will do a query, say land use to, add a clause land use to, land use to equals to residential there, and click add and click OK and fill out the form so that we will do summarize. In the attribute table, click OK and click run, and then we will do summarize statistics. Summarize. Okay, right click and NAT name right here, and we will do summarize. And in the geoprocessing tool, we will do union, and here we will say union in our Brooklyn neighborhood residential land use. We will say neighborhoods residential land use, and the field we will do poly area and the sum, and field name use is the NAT name, and then click Run. So open the Brooklyn Neighborhoods residential land use table, and we will sort for descending. Go to Open, okay, and now we will move everything and we will do descending. So when we do descending, the list will show neighborhood names with the highest to lowest residential land use. And we will use this NAT field, join the the Brooklyn Neighborhood Residential Land Use Table to Brooklyn Neighborhoods. So, open the table and we will sort descending by H units. Open the table for Brooklyn Neighborhoods. Okay, and then we will have H units, close this out. We don't need to use it anymore. And then we will do descending. A planner now can compare the neighborhoods with the highest number of housing units and the number of residential acres. So, poly area and the sum, we need to join them together. And right-click on the neighborhood, and we will go to Joins and Relates. Add join. So Brooklyn Neighborhoods join field. It's not. I don't think it's H units. That will be the NAT name. Yeah, NAT name. So NAT name. There. So there, okay, and then once we run, then we can add everything back in here. So neighborhoods, okay, back in neighborhoods. Sum poly area is right here, okay, and the field was added here, okay. And H units, we can just still do descending, okay, and then we can export it. This layer. We're going to close all the attribute table, and we will save everything, project, and save, and we will do the Queens neighborhood. So Queens neighborhood land use, we will do the same thing. Repeat the process, summarize residential land use. So the first part we have to, I think they gave us Union already. Let's see which union it is. I think I did this union. Maybe I accidentally clicked it wrong. But we will try it. Okay. And we turn on this layer. Let's see if it gets union already. There, I think it should be union. Land use too. And union here. Never mind, I will get used to this. Okay, I want to do half and a half so I can see everything at once. Okay, neighborhoods. So let's bring neighborhoods here. Okay, we have a neighborhood. Okay, neighborhood this and union 3, 4, 5 this. Okay, and I think we do have a union. And we don't need to do union. Summarize. So let's do the summarize of the residential land use. Summarize the residential land use. Which part is the residential land use? The acreage. Okay, shape area. Which summarize. Let's see, union. Okay, we did union. And the summarize, select summarize residential attribute, which field, area, okay, union. So it's on union, and then we will do tools and add geometry attributes. So we will do union, geometry property. That we will have is area. And length of union, it will be feet United States. And area unit, it will be acres. And coordinate system, it will be Queens. Okay, right here. So NAD 1983, State Plane, New York, Long Island. FIPS 3104 and feed their coordinates will